Alright, hello. So we are going to continue our discussion of Chapter 5, looking at forces in 2 dimensions, and talk about friction. Okay, there are 2 main kinds of friction, static and kinetic. And the big thing with friction is that it always acts to oppose motion. So kinetic friction is the force exerted on one surface by another when either one or both of the surfaces is moving. So if you are walking across the floor, that kinetic friction keeps you from slipping. When you go outside in the wintertime, if your hands are cold, you usually rub them together and it makes them warmer. That's due to kinetic friction. The surfaces are moving and creating this friction. The second kind of friction is static friction, and this is the force exerted on one surface by another when there's no motion between the 2 surfaces. So when you have a big box on the floor and you're trying to get it to move, that force that you're applying before you get it to move, that's the force acting against the force that you're pushing, that's the static friction. And then once you get it to move, now you're overcoming kinetic friction. So once an object is in motion, static friction becomes kinetic friction. Okay, so let's look at some causes of frictional force. So the materials that the surfaces are made of, if you think of like a smooth pavement versus a really rough pavement, let's say you're trying to rollerblade, it's going to be a lot more difficult to rollerblade on the rough surface. Same thing like if you're ice skating, it works much better if the ice is really smooth. There's going to be less friction in that case. Things that don't influence frictional force would be the surface area of contact, so how much of the 2 surfaces are in contact, or the speed of motion. Those things are not going to influence friction. So we've already talked a little bit about normal force. Remember, normal force for an object. Let's say we have an object sitting on a surface. And remember, the normal force is perpendicular to the surface of contact. So the harder one object is pushed against the other, the greater the force of friction. And so because the normal force is perpendicular to the force of friction, normal force and force due to friction are always at right angles to each other. So let's talk about ways that we can differentiate different friction based on different surfaces. So we said that kinetic friction force and normal force were perpendicular. They're also directly proportional to each other, meaning that they're related. And so we have what's called the coefficient of kinetic friction, and this Greek symbol is mu. So it's like a U with a tail on the front, which really isn't a tail, but that's how it's drawn. And if you take the slope of the line of the kinetic friction force versus the normal force, that's the coefficient of kinetic friction, is that slope. And so this is how we relate kinetic friction force and the normal force. So force due to friction kinetic is equal to the mu sub k, or the coefficient of kinetic friction, times the normal force. So, and then in words, kinetic friction force is equal to the coefficient of kinetic friction times the normal force. So if you wanted to put this equation on your note card, you could definitely do that. Okay, let's look at the coefficient of static friction. This is very similar to the coefficient for kinetic friction, but remember, static friction is when there's no motion. So if an object is sitting there and there's no force acting on it, then we would say that the static friction is 0. We can also take our coefficient of static friction and relate it to the force due to static friction and the normal force. But here, instead of an equal sign, where is the pen? We have a less than or equal sign, because when we're applying static friction, that's the force before it starts moving. And so that's the minimum amount of force, basically, to get an object to move. And then at that point, we're overcoming kinetic friction to keep it moving. So mu sub s times F of n is the maximum static friction force that must be overcome before motion can begin. And that's why it's a less than or equal to sign. So let's do a quick review. Okay, friction always acts in the direction opposite motion. So a lot of times they may not tell you what direction friction is acting in, but you'll know the direction of motion. The magnitude of the force of the friction depends on 2 things. The magnitude of the normal force between the 2 surfaces in contact, and then that coefficient. And before, we've talked about how the normal force and force due to gravity, if this is F sub n, and this is F sub g, and that those are equal and opposite. But now we're going to start talking about things at angles, and so no longer is the normal force going to be not perpendicular. No longer is the normal force going to be equal and opposite to gravity. So when we're looking at force due to friction, it's going to depend only on that normal force and the coefficient, not on the force due to gravity. If we multiply the coefficient of static friction and the normal force, that gives you the maximum static friction force that's required to overcome in order to get an object to move.